Greetings, Earth Scientists. It's Mr. Gopal here with another relevant, highly relevant lesson today on climate change. So as we explore the simulation, and let me take a step back and say this is part of Unit 8. It's on climate, Unit 8. It's day 7. We want to start examining how climate affects society today. This is the first part. We're going to take a look at a simulation about El Nino. Now, this is before your time, but El Nino was a rather devastating, highly destructive hurricane. And so examining hurricanes and other natural disasters can be a way to understand the effects of climate change. Before we go into it, though, what I'm going to do is I'm going to share my screen and talk about some basic trends and terms that you're likely to see. So when we talk about climate change, we need to distinguish climate from weather. Okay, so when I say climate, I'm talking about large-scale trends in weather patterns. On the other hand, when I talk about weather, I am talking about day-to-day temperature, storms, and you could say micro patterns, all right? Micro pattern, I mean something like, okay, it has begun to rain and possibly later, once the rain clears out, there might be a little bit of fog if you're against the bay. So that's a micro pattern because very often spells of rain are followed up by fog if you have, I guess, like interlocking air masses because you're on the edge between land and the sea. Okay, so climate change is a bigger deal because we have large-scale ways of looking at the weather, and they have changed over time. And that is what we refer to when we say climate instead of weather. I'll give you one example of a large-scale trend. We know that across the world, when it comes to spring and summer, we have longer days with warmer weather than we do for fall or winter. And the most extreme differences between winter and summer in terms of the length of the day and the average temperatures across those 3-month bands, okay? So this is a pattern that we see every year. Obviously, during the winter in New York, it gets cold. In the summer in New York, it gets very hot and humid. In between, we have kind of milder variants on both of those things during the spring and the fall. But this is an annual pattern in the climate of New York and most other places around the world. Of course, as we get more extreme, like, for example, farther away or right against the equator, we get farther away to the poles, we are not going to experience changes in the seasons as dramatically because those areas of the world are not exposed all that differently throughout the revolution around the sun. Same thing with the equator. The equator always gets lots of sunlight, so we don't experience dramatic seasonal pattern changes in the weather, okay? So this is a climate trend on an annual level. Now, a few other things that I'm just going to point out. We're going to flesh this out in future videos, but key concepts of climate change. Number one, we're going to talk about what it is, which is specifically on Earth. The reason why it's so dangerous is that there is a steady climate change on Earth. Change on Earth. There's a steady increase in the average temperature on Earth. You might ask yourself, why is this such a big deal? Well, for several reasons. For one, we know that, so reasons why this is dangerous. Number one, we know that greater average temperatures melt polar ice caps. This would be like 1A. The phenomenon 1B would be, as a result, the sea level rises. And as a result of that, coastal towns and regions are flooded. And of course, I'm talking about a very dramatic flooding. Okay, so we're talking about the destruction of entire communities. There are long-term effects to this. Not only are people displaced, but they might die in a flood. And there are also other effects. If they survive, but their house has been flooded, there's the risk of mold and other waterborne diseases and ill effects on a habitat. Okay, so that's really bad. Now, also, here's another set of reasons why this is dangerous. Certain arable lands, by arable, I'm going to say in a condition favorable for agriculture. So arable lands in warmer climates become unfarmable, so to speak, due to extreme temperatures. So this is shifting, the knock-on effect is that this is shifting, removes the ability, let me say it that way, this removes the ability to farm lands and feed certain people living in such areas. Okay, so not only is their occupation removed, but we don't have sufficient resources to feed them. And of course, that's bad because that will increase famine. Okay. And you could say a final effect is that more and more, and this is actually a cause and an effect. So actually, I'll go with the cause first in 3A. So due to the burning of fossil fuels, greater amounts of carbon dioxide are trapped in the atmosphere. This leads obviously to these are called greenhouse gases. So greenhouse gas trapping holds heat from the sun in the Earth's atmosphere, raising the temperature. The combination of greater pollution and extreme heat lowers the life expectancy of humans across the globe. So I hope with this little introduction, before we get to at least the basics of, you could say, multimodal literacy, which is what we're going to cover as we look at this El Nino series of interactive diagrams. Hopefully all of these different effects, as you chart down through them, you say, oh, you know what, this is really serious. This is very bad for the Earth. We need to understand this so that we can do something about it. So with that, we are going to go to simulation. And my purpose here is just a quick introduction to part one so that we can understand how to read these charts and properly suss out what's going on. So I'm just going to spend a little time on level one and then talk a little bit about what to expect in future levels, all right, and how to interpret it. So with level one, we are looking at sea surface temperature. And so as I said before, one effect of climate change is the melting of the polar ice caps. Greater and greater amounts of ice that has been frozen for many, many centuries is now melting. You could say many, many millennia even. This is very old ice. And so it's melting, it is flooding the sea, and because of greater amounts of heat being trapped in the atmosphere, the temperature of the sea is rising. Another effect that I didn't talk about is the reduction of biodiversity in the oceans. Okay, so fewer of like the various types of sea life that exist today can survive and prosper with higher sea temperatures. So we're seeing a reduction in the biodiversity of that particular ecosystem. another very deleterious effect of climate change. So if we're looking at this map, we've got what we would call a heat map of the Earth. And then we also have both the latitude and longitude listed. So we've got these latitudes up the side. Latitudes tell us how many degrees north or south we are of the equator, which is the midline of the Earth. And degrees are a certain measurement for blocking out, I guess, large distances, you could say, across the Earth. Longitude, on the other hand, runs long or up and down, and that marks out how far east or west we are of sort of our vertical middle of the Earth, which, as you can see right here, it passes through West Africa and through Europe. Okay, so latitude is of far more import when we talk about climate change. So we've got this idea, and we've got sea surface temperature. And what we can see from the key is that if we go from the very, very dark blue, we're talking about very, very cold water. Okay, and obviously as we drift towards the poles, it becomes colder. As we go farther towards the equator, we can see that the sea surface temperature rises dramatically all the way up to 32°C, which is a very high temperature. I'll remind you, I'll write the equation right here, but if we're converting between Fahrenheit and Celsius, and you need a better idea of this, so F is going to equal 9/5 times the temperature in Celsius plus 32 degrees. Okay. So we know that we're going to multiply that by almost 2, 32, and then we're going to add 32 onto that. So roughly we'd have almost 64, all right, about 60. And then we'd add 32 on that. So we're talking about in the middle, about 90° Fahrenheit water. So you can see why that starts to pose a grave danger. I'm going to clear that calculation. And now let's talk about interpreting this. So you have to identify locations on the map using the latitude and longitude that you're given. As I said, we have north or south of the equator. For latitude, we have east or west of this vertical midline, the prime meridian, okay? And now if we move down, I say false colored maps because this is obviously not the actual color of the water on the Earth, all right? And we've got 2 questions here. Think it over. I'm not going to answer them myself, but you want to think to yourself, based on what I've indicated, what do lines of latitude tell us, all right? And then, according to the map, the average monthly sea surface temperature at 5° north and 140 degrees west is approximately what? And this is going to start getting into patterns, okay? So I can see west down here. It's a little bit hard to see, but here's the prime meridian going up and down, and this way is west. And if I go all the way to the edge of the map, here's 135 west, and I need to go a little bit farther, about to here, to get to 140. And that's how I find my longitude. Now I have to go to 5 degrees north, which means I have to get to 0, and then go about a third of the way through here. And so we've got a very deep, dark temperature. I'm going to let you interpret that, but this is just a brief introduction into using the map to make inferences about the temperature of the water, the sea surface temperature, that is, at different places on the map. And now we've got one more map, all right? And so we're going to compare change over time, all right? We've got 1990 versus 1991, okay? And so in order to scroll through this, first I can extend this. And then when I'm ready, okay, so this looks pretty familiar. This looks very similar, okay, to what we were seeing before. All right. Oh, I'm sorry, I'm scrolling in and out. I'm just getting used to the toggling. All right. And now if we scroll farther down, we can get to 1992. All right. And I'm just going to make a few observations. Let's take New York, for example. I'm going to zoom in a little bit. And then I'm going to adjust so we can look at New York. This is 1992 because I scrolled farther down. And we can see that we have a pretty warm temperature. It looks like it's in the yellowish region, which is pretty high, pretty far to the right on my sea surface temperature spectrum. Now, if I go back up, I can look at 91. I can extend this over. And now I can zoom in and see New York again. Oh, I'm sorry, this thing is a little bit hard to adjust. Try to zoom in one more time. And I can see New York just 1 year earlier, far different. It is in the 8 to 17 degree region. 1 year later, it's like that. And so it says, discuss and compare these two maps. How are the maps alike? And I really like question number 3. Why is it important for researchers to look at data for more than 1 year to determine sea surface temperature change? So this brings me back to the point that I made at the very beginning of this lesson about the difference between climate and weather, okay? We were looking at micro patterns, day-to-day patterns in weather. When we're looking at climate, we were looking at yearly, decade-long, century-long patterns even, millennia-long patterns even, because that's how we get a sense of the way that the world works, okay? So you might struggle a little bit with the technical aspects of this particular interactive, but I encourage you to continue from level 1 through level 5 to get a really clear picture of this. It's such an important topic, and I hope that my summary at the beginning and some of the examination, this interactive, will have convinced you that climate change is a big deal. There are a lot of deleterious or negative effects from it, okay? And it's our responsibility to understand the problem so that we can fight it and ensure the continued prosperity of human beings on Earth. I hope this was helpful to you. Thank you very much, and I will see you next time.